Okay, I haven't made a video for a while, and this is the main reason why. I've been busy working on this. This is my Murphy Renegade, one of my other Murphy Renegades. This is the other one. This one's operational. Just for the sheer hell of it, I thought I would do a video on something simple, really super duper simple. How to make holes in aeroplanes. Yeah, if you're interested, come along, let's have a look. Here's my little workbench that I set up in the sun. And if you're in any way thinking about building any sort of aeroplane at all, this would be common to all types of aeroplanes. They need holes. You need to make holes to put fasteners in to hold the aeroplane together. So I've got some scrap material. I've got plenty more scrap material over there, and we'll see how some of these different machines do their business. Yeah, how they go about making holes. Here's what most people would have in their workshop: a simple drill. This is a fairly big one. You're probably better off with a much smaller one than this. But if this is all you've got, this will make holes, no question. It weighs a ton, and if you drill lots of holes with this, you're going to wind up like one of those deep sea crabs with one great big claw and one little claw. But that's okay, you'll be able to make holes. A 1/4 inch drill would be a much better proposition, the smaller ones, the cheapest ones that you can get from the hardware store, but this will do it. Now, the added advantage of this is it has a hammer function. So if you're building a ferro cement aeroplane, this is the tool for you, no problem. You'll be able to drill holes in concrete, no worries at all. Yeah, it will turn a reasonably small drill. This size drill you will become very familiar with. This.
Tomorrow, talking about Charlie. Keep 10 space from right there, not touching guy. Tomorrow.
Yeah, I live at the airport, and we've got a Tiger Moth flying right now. This drill size. Let's start right back at the start. Drills come in different sizes, obviously. They come in metric size, which will be in probably 0.1 or 0.2 of a millimetre steps, up to whatever size, up to great big stuff for heavy machinery and bulldozers and stuff and beyond. They also come in imperial sizes. The British love doing this with typically in 32nds of an inch or 64ths of an inch. And that makes it a little bit difficult. There's also a series of drills that come in numbers, like from number 1 to number 50 or 60, I think it is. This particular one is a number 40. And just in case you actually start to work out the system, the bigger numbers are smaller drills. So a 50 or 60 would be a little tiny thing. This one's a number 40. This one in this machine is a number 30. Yeah. And they also come in letter drills, like A to Z, I guess. With aeroplanes, you'll mostly be working with number drills or maybe metric ones. Okay? This particular one, there's the tiger moth again. This particular one is a number 40 cobalt split point drill. I found these to be the best. This machine will drill, I guess, if it'll hold the drill, then it'll make that size hole. Let's see if it'll do it. Well, maybe. Righto. The problem with this is not only heavy, but it doesn't spin very fast. And with the smaller the drill, the higher the speed you require. I'll hold this down. Oh, that's the hammer function. Okay, we're not building the cement aeroplane. We'll go on to the drill function. And that made a reasonably nice hole that looks round. Looks pretty good. I don't know, can you see that? Maybe. Yeah, not very well, but they are round holes. It does a pretty good job. Okay, so that will do the job. But two things. One, it's heavy. And two, you're working around sheet metal. And when you pull, we'll just put that down here for a second. When you pull the cord, let's get that out of the way. When you pull the cord up over a piece of sheet metal, you run the risk, let's say that's a rib or something that's in the aeroplane. You do run the risk of this coming open a little bit and falling down into that gap, and the plugs falling down. Okay, so they've put some...
Charlie X-ray Yankee 10 space runway 09 touching go.
They've put some insulation here so that you don't accidentally drop something down here, but not all plugs look like that. In some countries they don't look anything like that at all. This rim stops that from happening. But if you're going to use an electric drill, you really need to make sure that if this is all you've got, put it together and maybe tape it up so it doesn't come apart, doesn't run the risk of falling in to a piece of sheet metal. Yeah? But it'll work. It'll work. It is heavy, but it'll work. And we just proved that it'll drill a very nice hole. Thank you very much. Righto, let's have a look at the next. We'll put that aside and we'll look at the next machine. The next machine would be a battery drill. It doesn't require a cord, so it's a bit better from that perspective. It has this particular one's a 2-speed one, and to drill those small holes, we need a fairly high speed, and it will go fairly high speed. Let's just do that up. Yeah, there we go. Radio's not keen on it. And again, it drilled a reasonably nice hole. I've been using that drill. It's not brand new, but it's... I know it's probably more interesting than me, but anyway. So yeah, it does spin. It's not real fast, which is why it took a while to drill that hole. Let's just take it out of there. But you can use it. Like I say, it's heavy and it's big. It's a bit awkward to get into some locations. But if that's all you've got, it'll work. Okay. That brings us to the next arrangement, which pneumatic drills, air-operated pneumatic drills, or air-operated drills. This is my absolute favourite. It's expensive compared to this one. This one is probably the cheapest you can buy at the hardware store. It might cost, I don't know, maybe $100. This one's more than $200. And the main reason for that is it's smaller, it's lighter, and it spins a lot faster. Let me show you that. I'll put a drill in there. Same size drill. This particular one is is very, very old. I've had it for maybe 15 years. No, maybe 20 years. One of my friends found it, believe it or not, at the rubbish tip. And I cleaned it up, put a new chuck on it, and made it go. And it's done a fantastic job ever since. Let me demonstrate this one. Unfortunately, we need an air source, so we need a compressor. But that's okay. If you do build an aeroplane, you're probably going to want to paint it yourself anyway. So you're going to need an air supply to run the paint gun. Here's two things. Have a look how fast it spins, and have a look how quick it stops. When you take your finger off the trigger, it stops immediately. The electric drills won't do that. They'll spin on. So let's see about drilling a hole. I wasn't pressing on that. That was very slow. Drills a hole. It's pretty quick. It's light. It's small. It gets into most places. Let's just sit it there for a minute because we're going to come back to it. This one. This is a 3/8 size drill. 3/8 is big. It'll take a much bigger drill in this chuck. That one's 1/4 inch drill. The biggest drill it'll take is 1/4 inch, which is whatever, 7 millimeters or something. This one will take 10 millimeters or 3/8. That's a number 30 drill that's in there now. Number 30 is a little tiny bit bigger than 1/8. A number 40 is a little bit tiny bigger than a 332. There's a reason for that. Most rivets and aeroplanes are usually riveted together, and bolts, or bolted together, are either 332 or 1/8. You start getting bigger than that, you start getting into big aeroplanes. We're not going into big aeroplanes, we're only going to build small ones. Ordinarily, when you drill holes, you'll drill the smallest one you can and then enlarge it to the next size up. That's just, you really need to get into the habit of that. You don't go straight for the size you need and drill as big as you can. Let's open this one up to 1/8. Well, for starters, you can see that it still stops quickly, but it doesn't spin very fast. And it looks like that drill is bent as well. I'll show you how to straighten a drill bit that's bent. Yeah, it's not too bad, but if you put it on here and push up on it, believe it or not, that is straighter than it was. Not much. Okay? If you're going to get pneumatic, go for the smallest one you can, not the biggest one. You might only ever need, you might only ever need a couple of holes, big holes. We'll use that electric one. We'll use that battery one to do those few big holes that you might come across one day. Don't go and buy a big pneumatic drill. That would be a waste of money. And not a reversing pneumatic drill either. That's another waste of money. This one, both of these drills only go frontwards. Okay. All right. Now let's see. Here's another scrap piece. Let's say we've got a rib. All right. Here's our rib. A pretend rib, and it could be like that. Okay. And we want to drill a hole in here. Now, if it's like this and it's free and it's open, you can bend it out of the way a little bit and drill your hole. No problem. But what if it's attached? It might be attached to a whole bunch of other structure. How are we going to get in there? Well, then you can use this, and I wouldn't recommend buying one of these either because this is expensive. You can buy just that bit, that front part, or similar to that attaches to a normal drill. And so you use the drill as the motion, the turning motion, and you use this to get in close. As you can see, it can get in very close. This particular one is a number 40 drill bit. It's threaded into this machine. Yeah, and you can get reasonably close. You can get within, within a few millimetres. Like the other drills, it spins quickly. Actually, it sounds a bit like the dentist, doesn't it? Okay, we'll just have a little rest there for a minute. So let's say you want to drill in here. This can get in and drill without bending the structure out of the way. The structure's fixed. Most of that drilling was making that hole in the wood, not the one in the metal. But there you go. You can get in close. This thing's dear. Don't buy it. Buy the front part or don't buy anything. Is there some other way to do it? Let me show you. Use long series drills. Now, we put them in this machine. Okay, so you may be able to come in here without bending the structure out of the way. That will work. Ideally, you should be drilling at 90 degrees to the surface. You don't try and drill on an angle. That's not the way to do it. You need to drill straight like that. This is a 6-inch drill. You getting the picture that most things are in imperial measurements? It's because most aeroplanes are built in the US. Okay, I know it's going to insult some people from Europe, but unfortunately, that's how it is. Or fortunately, depending on your point of view. This is a 12-inch drill. You can actually drill with this. You can bend it and drill. For instance, it'll drill quite well like that. Yeah, so if you want to get into that structure, we could, if we wanted to drill a hole there somewhere, bend this, whatever, but bend it like this. We can't get the machine in, but we can get the drill bit in. And there we go. Had to happen sooner or later. We wanted a bigger hole. Okay, you don't want a little skinny hole like this. You want to put, I don't know, a switch. You want to install a switch on an instrument panel, for instance. You're going to need a much bigger hole than that. These little machines are not going to take a great big drill to the size of a switch. you know, which is probably 12 millimeters or half an inch. Let's say we're going to install a switch in here, in this piece. I'm going to go with a different tool this time, and I'm not going to hand hold it like I have been with the other drills. Let's just make a hole in here somewhere. Let's say about there. That's where our switch is going to go. And we'll put it over here somewhere where it's out of the way. And now we're going to fasten it down with a clamp. Now, this clamp would bruise the metal, so you put, you know, if you were doing this on your real aeroplane, you'd probably put some packer or something so that it doesn't damage the material. We might go with the battery drill this time, and we're going to use this step drill. This step drill will give us the size we need to put our switch in. Actually, I've got a switch there. We might install the switch. Here's the switch. Yeah, this is typical. You're building your instrument panel now. You've finished all the rest of the aeroplane, and you're going to install this. We need to drill a hole that's that size. Oh, that could be fun. Let's have a go at it. This machine, this drill, will make light work of that. Whoops, that's not very good. Let's move it over here somewhere. We want to slow it down a little bit. That's too fast. That's better. That's a 1/4 inch, I think. Whatever the next size up is. Yeah, we're still not there yet. That might fit our switch. No, a little bit bigger. Look at the ease of that. This is a brilliant thing. They're dear too. That's probably about more than $50 for that. And there's our switch. Get our instrument panel out of there. The hole is really quite round, although this one doesn't look too round. Probably because it came up on the side of this wooden piece. What we can do is deburr the hole from the other side, turn it very, very gently, and let the machine cut the burr off, because it does make a burr. Put the switch in, and there we go. That's the worst round hole I've ever done with one of these tools. This is a brilliant tool, fantastic tool. And there it is. There's your switch installed in your. This is your pretend instrument panel now. Oh wow! Didn't know it was so hard to make holes, did you? Well, we haven't finished yet. Don't send any money just yet. We've got a set of steak knives coming as well. Let's say you want to install an instrument now. You're still on the instrument panel, and we're going to need a bigger instrument panel if we're going to put an instrument in. This size instrument panel was fine for a switch, but for an instrument, righto, here's a little bit bigger instrument panel than what we had before. And we've got, let's see, there's an instrument. This is going to be the size of our instrument. It's unfortunately it isn't. This hole saw is good for, it's slightly small. This is 51 millimeters, and I think the it's 51 millimetres. The instrument I think is 52 millimetres. Of course it would be 52 millimetres. But anyway, we'll use our battery drill again because it's nice and slow turning. We don't need to spin this fast. If it'll fit. Oh, it'll fit. I don't want to drill my toolbox, so we'll drill over here and hopefully miss. Can you see that? You might have to come around a little bit more. Okay. There you go. Let me see. About there somewhere we want our instrument. This way. Well, there it is. Yeah, you wouldn't do this freehand like I just did. There's our coupon out. Here's our instrument panel. I had an instrument somewhere the other day. Obviously you would clean this up with I'll show you that in a minute too, with another tool, but our instrument panel's pretty skinny. You'd probably use a thicker instrument panel and that instrument would go in there. Like I say, that cuts a 51 millimetre hole, the instrument's 52. So I need to buy another one of these, another hole saw. Okay. All right. Well, that's fine. What if you wanted to make a big instrument, a flight instrument? Now, a flight instrument is 3 1/8, I think, for a flight instrument. Okay, here's our flight instrument. This one's a VSI, vertical speed indicator. All right, we need to measure this up for starters. I'm pretty sure it's 3 1/8 or 3 1/16. Let's have a look. Yeah, so that's our clearance for it. Or actually, it's going to fit on this side. A little bit bigger. Okay, that's about the size we want there. We need a bigger instrument panel again. I'm going through instrument panels like there's no tomorrow. And if we measure that up, it's about 3 1/8. Can you see that? About 3 1/8. What a weird looking ruler this would be. I'll show you that. This is called a centre finding rule. If we want to find, I don't know, the centre, let's say, we want to find the centre halfway between those two. And we've got all these weird, you know, 8ths and 16ths and all sorts of things. Well, you don't use them. You just make sure the same amount of numbers are sticking out that side as what sticks out this side. In this case, it's about 1 inch. Matter of fact, it's exactly 1 inch. 1 inch sticking out there and 1 inch sticking out there. There is the centre between those 2 points. Yeah? Beautiful thing. Incredibly good. Right, I'll go find a bigger instrument panel and I'll get back to you. Here's something that I promised to show was we cut that coupon out and it was pretty rough. It was like this, it was pretty rough around the edges. You can't have that on your instrument panel, obviously. Well, how do we clean that up? Well, we use this thing. This is a Scotch-Brite wheel. Scotch-Brite, you know, like the thing, the pad for washing up, but it's made into a wheel. Put it on the drill or preferably the die grinder so that it spins at 97 gazillion miles an hour, and we run it around in there and clean the edges up. Now that will be really, it's not going to make it, well, if you wanted to spend 10 minutes there, you could make it big enough to fit the 52mm instrument, but all we're trying to do is clean it up. There's a little bit of a burr still there. We can take that off. Which, that's reasonably good. Reasonably good. If I spent time on it, I could make it better. But I'm probably not going to use this instrument panel. It's a little bit too fragile. Right. Okay, so now we're going to put a bigger hole. Okay. What was it? 3 1/8. Here's our instrument panel again. Well, the instrument goes in from the back. Oh, that one's not going to work. Okay. I bought this stupid tool. I think it's for cutting holes in drywall, in gyprock, so that you can install light fittings or something. Almost everything that will put a hole in wood will work on aluminium. Don't try it on steel, but it will, or stainless steel in particular, but most woodworking tools will work on aluminium. Now the test is whether gyprock tools are going to work on aluminium. Where's the... Okay, I'll drill that hole. I will drill it. This is a bit slow, but I'm not going to speed it up. Hopefully it'll reach. Yep. Okay, well. All right. We'll come up here a bit. To about there. That's more or less in the middle of the hole in here. Fantastic. And then just chuck a hole, I don't know, fit over there. Yep, that'll fit over there. I don't want to waste this. I might be able to use this for something later on in the construction process. But, so it's just, at the moment, it's just scrap. So we'll put a hole about there. This plastic, this aluminium has plastic coating as well. Okay. And that's 1/4 inch drill. Here's our gyprock drywall tool. I've got faith in it. I think it'll work. What we might do is just try it out on our piece of wood for starters. it needs to be 3 1/8, so 1 9/16. That's 2. That's not what it wants to be. Inch and 9/16. That's fairly close right there. So we might try and put that about there. If this does pick up, we want to go and bang against there, so we might as well put it against there in the first place. Just barely cut the plastic. Okay. There's our circle where our instrument's going to go. Smaller than this one. Remember, this was too big for the instrument. This circle is about 3 1/16. So it needs to be a little tiny bit bigger. We can do it this way, I suppose. We can lock that down there, like that. And it needs to be about there. See how that looks. That is. I'll bring it over here where you can see it maybe. That's pretty damn close to 3 1/8. It's a tiny little bit bigger than 3 1/8. That's okay, that's what we want. Put that over there. We've got the piece of wood under there. I don't want to cut into the steel bench of the drill. Piece of cake. Now obviously it's rough, it's got burrs which we can take off with the Scotch-Brite wheel. Now here's our flight instrument, here's our instrument panel. Look at that. Might not be perfect, but it's pretty damn close to it. Yeah, then you've got to find the holes to mount the instrument there. Yeah, piece of cake though. Okay. Oh, there was another. Actually the drywall thing worked pretty good for skinny metal. I don't know how it'd be if it was on a proper 3mm thick instrument panel, I don't know if it coped with that very well. One of my neighbours loaned me this fly cutter, which is a proper fly cutter for doing thicker material. So we'll give it a go. What the heck? We've got nothing to lose, and we've got all afternoon to do it. What have we got here? Oh, it's just round, okay. This is not my tool. My tool is in Peru. You're not going to believe that. I took it there and I've left it there. This is where we were going to put it, remember, in this one. These things don't drill very well. Usually these spigots are pretty horrible. There it is, lined up there. This circle is the size of the instrument. Well, that's not too bad. It might be slightly bigger than the one I made with the drywall tool. Let's see how we go. Right. Bring that over there, bring that there. Okay. This is what proper tools should do. There was much in it for this thin material. This is I think it's 16 gauge. It's pretty thin. There's our coupon. This is a proper tool for the job. Where's our instrument? Oh, okay, so it was a little bit smaller. But you get the picture anyway. It's a tiny bit smaller than the one I did with the that one's near enough to perfect. Matter of fact, that would be perfect. Yeah, this one's just a little bit tight. Okay. But that's how you do it. We didn't hurt ourselves. We didn't risk our neck or our fingers. I've still got all the ones I started with. And yeah, same deal. Use the Scotch-Brite wheel, whiz them out, make them nice and smooth. There's your instrument panel. Yeah, pretty neat, pretty easy. Oh, all right. Let's come into the shade here where you probably can't see me. What if we wanted to do a bigger hole, bigger than that fly cutter is capable of? How do we do that? My God. If it's that big, you can drill a hole, put the tin snips in and snip it around. I actually have a machine called a nibbler, which is like a little beak, and it'll. Then you've got all these bite marks all over the place that you've got to smooth out, some with a rotary file or whatever. But you can make an even bigger hole. That fly cutter will make quite a big hole if you wanted it to. It'll go. It'll go probably up to 8 or 10 inch hole or something like that. You can just let me line that up again. Yeah, here we go. You can let's turn this around. There's a couple of Allen keys here. This one holds the pilot drill in. This one holds this bar. So you can move the bar all the way to this end. So you've got this much bar sticking out. So you've got double that distance in a circle. That'll, that's a pretty big hole. This tool will cut. They're a good tool, and not that expensive. Well, it's not that expensive if you get the Gyprock one, the drywall one, off the internet. I think this thing cost me less than $15. I mean, and it works. It did the job. It cut a hole. Matter of fact, it cut a perfect hole for the instrument. So, it's up to you to account for what you think is worth spending on your tools. How I make holes in my aeroplane. Yeah, how you do it, completely up to you. Whether or not here's some holes I prepared earlier. For instance, it's not difficult. It's just time consuming. That's all. I'll whiz you around this direction, and you can have a look at an aileron, for instance. Here's a lower aileron. And look at all those lightning holes. They're not there for any other purpose than to make the aileron lighter. And if you look forward, a little bit further forward than the aileron, that's the main spar. And the main spar's got lightning holes as well. Matter of fact, I've put lightning holes wherever the drawing said they were optional. Yeah? In my opinion, they're not optional. In my opinion, you keep the aeroplane as light as possible, and this is one way to do it with these lightning holes. Here they are. They're not very big, what, inch and a quarter or inch and a half or something. They're not very big, and they probably make a few ounces worth of difference. But you need to get your mindset into every single place you can lighten the aeroplane, you do. Yeah. In a previous life, I worked in an aircraft factory where we made aeroplanes that seated around. I've got to show you this front end again. This is my beautiful Rotec radial engine. I worked at a factory where we made about a 12-seat aeroplane, and we went through a lightning regime, and we were able to lighten the aeroplane about 1 passenger worth of weight by cutting lightning holes, by making sure that we didn't put half a dozen washers under. Well, you wouldn't put half a dozen, but not putting too many washers under a bolt, making the bolt just exactly the length you wanted it, not any longer. Using skinny washers if you could get away with it, and we saved about the weight of 1 passenger. So it's worth it. It's worth it every time, every single time. But anyway, that's it. Hope you enjoyed it. I hope you didn't get too annoyed with the with the air traffic on the radio. That's you know, it is an active airfield. I'll just show you down the airfield. There's a museum down there on the left at the end of that taxiway. Those big buildings on the left, the blue ones. We've got, these are all house and hangar blocks. This is an aviation estate where I live. This is one I built earlier. That one has the propaganda says 13,000 rivets holding that airplane together. So you tend to get good at drilling holes. Matter of fact, you get really good at drilling holes to take rivets back out again. That's the thing. But yeah. So anyway, that's me for the day. I'll continue with my work, and I'll talk to you later. So bye.